Okay. Next is stratified sampling. Stratified random sampling involves dividing the population into two or more subgroups or strata prior to sampling. Strata are generally delineated in such manner that the sampling units within the same stratum are very similar, while the units between strata are very different. Simple random samples are taken within each stratum. Strata should be defined based on the response of the attributes you are estimating to habitat characteristics that are unlikely to change over time. Examples of characteristics that might be used to delineate strata are soil type, major vegetation types such as forest or grassland or farmland, and soil moisture. You should avoid defining strata based on characteristics related to the attribute you are estimating, since this is likely to change with time, leaving you stuck with strata that are no longer meaningful. For example, if you are interested in estimating the density of species X, and you note that the east half of the area, okay, it is half of the target population, is much more densely populated than the west half. Avoid basing your strata on this fact alone. Okay, if there is an obvious habitat feature responsible for this difference, such as aspect, then base your strata on this habitat feature. If there is no obvious reason for the difference, you probably better off using a simple random sampling procedure, because you might find that your management will result in more recruitment of species X into the west half of the target population, leaving you with a stratified random sampling procedure that is less efficient than simple random sampling. This figure shows a nature reserve with a valley running through it. A certain species of rare plants will be counted in 15 quadrats. So the top figure, okay, this A, shows a simple random sample where by chance 10 of the quadrats landed on the plateau, 3 landed in the valley, and only 2 on the left of the plateau. So, but in the bottom figure here shows a stratified random design where an equal number of sampling units is allocated to each to the strata. So here you have 4, this is you have 5, also they have a little bit 5. Okay. So the major disadvantage of stratified, right? The major advantage, sorry, of stratified random sampling is an increase in the efficiency of population estimation over simple random sampling when the attribute of interest responds very differently to some clearly defined habitat features that can be treated as strata. Okay, so you can find the different in the oil palm plantation. Let's say you want to find a certain weed. Okay, you can find the different weed in the oil palm plantation, probably of the human disturbed area in the this aquaculture area, or probably in the secondary forest. So probably you can have a different vegetation from these three different sites. If you, let's say, you want to look at one species, so you can find these differences between the strata. So, however, the principal disadvantages, sorry, the principal disadvantage is the more complicated formula that must be used both to determine sample size allocation to each stratum and to estimate means and standard errors. Since we are taking a simple random sample within each stratum, the possibility exists that simply by chance areas within one or more strata may be left unsampled. Additionally, each stratum should be somewhat homogeneous and cover relatively small geographical area. Otherwise, the method will be less efficient than systematic and restricted random sampling. So, random, systematic, and stratified sampling, which should you use?